The next three questions are similar in that we are given the velocity, but then we're asked to find the position for one question, max velocity, and then max acceleration. The velocity of mass A is defined by the relation v of t equals 2.5 times zero point 0.7 sine of 0.7 t, where v and t are expressed in millimeters per second and seconds respectively. If the position of mass A at time equals 0 is negative 2.5 millimeters, what is the position of A when time equals 2.2? We want to take the antiderivative of the velocity equation to find a position equation. The position equation we get is negative 5 cosine of 7 over 10t over 2 plus c. Plus c is our universal constant. We want to find the value of our plus c, so we'll use our initial conditions given. When time equals 0, the position is negative 2.5 millimeters. So we'll plug those values in to find our value for c. When we evaluate, cosine of 0 is 1, so then it's negative 5 over 2 times 1, which is negative 5 over 2. Negative 5 over 2 can be expressed as a decimal as negative 2.5. That way it's easier to see when we add 2.5 to the other side, our c value is 0. Plugging in our c value into the position equation, we can now use the position equation evaluated at time 2.2 to find the position. When we evaluate the function at 2.2, we get a decimal approximation of negative 0.0769786. The next question asks to find the maximum velocity of mass A. To find the maximum velocity, we'll set the acceleration equal to 0 and plug that time into the velocity equation. We'll start by taking the derivative of the velocity equation. That gives us the acceleration equation is 13 cosine t over 5. Setting this equal to 0, we get t values pi over 2 and 3 pi over 2. Evaluating the velocity function at pi over 2, we get an approximation of 2.6. This question asks, what is the maximum acceleration of A? We'll start by taking the derivative of the velocity equation to find the acceleration equation. When we take the derivative of velocity, we get the acceleration equation is 136 cosine 4 over 5t over 125. Taking the derivative of the acceleration equation, we get negative 544 sine of 4 over 5t over 625. Setting the derivative of acceleration equal to 0 will give us the t value where acceleration is maximum. When we evaluate, we get that the t value is 5 pi over 4. Plugging 5 pi over 4 into the acceleration equation, we get an approximate 1.088.